it almost sounds, I mean, everybody gets up and says, hey, Vancouver, it's great to be here, but I have such great memories and pivotal events that happened in my life in Vancouver. So, I mean, you can trust me when I say, hey, Vancouver, it's great to be here. So,
yeah, I'm Bryan Oliver, as I mentioned. It's good to be here as well. I know quite a few of you from past GitOps events, like at the Weave company. It's good to see old friends. So, really excited to be here. All right. So today we have a little story to tell you in the beginning, and then we'll get into what we're here to talk about. So in 1979, two brothers, Hubert and Stuart Dreyfus, conducted a study. In this study, they were trying to understand one simple thing, which is how individuals acquire mastery or skills, understanding the levels of mastery. They particularly took a look at airline pilots and how airline pilots respond to emergency situations or an emergency response procedure. In this study, they had novice pilots and they had expert pilots. And they had the expert pilots write a script or a playbook, if you will, that the novices could follow in order to do emergency response more rapidly. The experts in this study were mostly instructors, so they were pretty familiar with giving them some, maybe series of steps. In that study, they found that when the novices used the playbook, they obviously were much faster, they were more performant, they made better decisions in any given emergency response situation. But then they turned around and had the experts follow their own playbook. And as many of you are probably familiar with in tech, this doesn't always go so well. The experts, when they use their own playbook, their performance dramatically reduced compared to when they weren't using it at all. So why do we think this is? Well, when they took a closer look at those experts in particular, and when they removed the playbook from their hands, they noticed that in every single emergency response situation, those experts weren't using any scanning pattern. There was no, like in the novice case, there was usually some sort of series of like, check, this dial, this dial, this dial, flip this thing, whatever. And the experts, they almost, in every situation, responded differently. And this is because at the highest level of expertise and mastery, they concluded that intuition is the primary form of decision-making. This study actually ended up creating the 5 stages of expertise and mastery, which are used today in the field of nursing and several other fields. And the deciding, pivotal point of level 5, or expert or master level, is you are no longer using scripts or documentation. You are pretty much using intuition for every single decision you make. To draw a parallel to technology, if any of you have read the Phoenix Project, which I assume most of you have, if you've ever worked with that character Brent in real life, when you pull Brent into an emergency situation or an outage, if you told Brent to use a script, it would slow him down. And in most cases, if you've pulled that person in, it's because the script no longer applies, or it's not going to work for that given scenario. And in many cases, by the time you're not even finished describing the problem to this person, they already kind of know what to do next or where to look. It would kind of be like in the SRE world where you have maybe a level 1, level 2, level 3. By the time you've called the level 3, you've already gone through the scripts and the playbooks, and you just need somebody that knows what to do next. They need to use that intuition. So if any of you have read the book, The Software Craftsman by Sandro Mancuso, he talks about how agile without technical excellence is just process. He also talks about the reverse of this, which is that when you have technical excellence, when you have expert programmers, when you have seniors in their field or domain experts on your teams, but you have an overbearing, poorly defined process, the same exact value-reducing thing occurs in that you're not utilizing those experts as you're not getting value out of them. So today we're going to talk to you about an enabling pattern that massively reduces friction and gives you a process that will work well with those experts and those people that use their intuition. Yeah.
What sort of compliance are we talking about? One answer could be what we'll do in the next few slides. It's the compliance that most of us are used to seeing in a CI/CD pipeline. But the takeaway we want to introduce early on is that really, as you engage in this exercise within your organization, it's all the compliance that might be in there. Contractual obligations, PCI, things like that. Could be governmental regulation in the form of a lot of different things. It could be SOX compliance. Internal processes that your organization just practices as a way of meeting investor and shareholder requirements. All those things that translate into work that might appear in a developer's life really can be subject to this. And if you think about it, more and more, the Venn diagram of the overlap of those things is starting to look like a circle. But we're going to focus in on one particular set of areas that's really central to CI/CD. So how many here have heard of continuous delivery? It's like, who is this guy? But the second question is the more ironic one. And how many here have heard of Thoughtworks? It's like, okay, it's not too bad. I don't know if you realize when Jez and Dave Farley wrote that book, they were thought workers. And they've been amazing contributors to this space. But the domain of thinking about using automation and using CI and CD for a developer to do his job, we introduced that with cruise control. And it's something that's central to what we were doing. It's what we do today, what we will be doing in the future. And we're always thinking about what's the impact of that? Is it benefiting it? It really has become, in essence, and was for a long time, central tool of the trade, surgeon's scalpel for developers. And it's morphed from there. It looks somewhat different. Probably around 2009 or so, it was like Jenkins made it onto IT ops radar. Not surprisingly, they're the sort of the first line for a lot of stakeholders within an organization that have compliance needs, financial needs, you name it, and they will kind of look to IT ops to get those things done. So they saw an opportunity from a sort of traditional human division of responsibility way to deal with that, and by seizing control of the pipeline and saying, we'll address these things here, we'll set out our goal, and then we'll make it your responsibility, and that's what we'll tell the auditors as we move forward. But if you think about what Bryan was talking about, what effect does that have on your developers as they increase in their knowledge of the domain in which they're shipping, and as their general skills grow, it begins to have a very high friction opposite outcome effect. Maybe not in terms of compliance strictly, but certainly in terms of the productivity of what is a very expensive and human, labor-intensive activity. So we're going to just focus in on sort of the everyday piece of that and what goes on in these pipelines. Some of these have always been a part of developers' concerns. Those engineering standards that as a team they put together and want to hold themselves to, they're continuously building their code, how they maintain it inside of Git. They've always been there, but there's a whole lot of other things that we do right now and have been growing and doing that go much deeper than that. Security issues, cost controls, data protection. We can think about all the ones that are there. It's kind of another lens of looking at it. A lot of the static and dynamic testing that goes on. We found a way to do that there. But how does this end up looking? How does this, how did it begin when the pipeline, was visible to everyone and they wanted to get control of it and use it? That is a content-dense slide, which I made, so it's my fault. But it really captures, here's real life informing art. How many of us really are familiar with this experience when you're out there working? By natural design, I guess, from the way we traditionally work, generally accepted accounting principles, you name it, we created all these separate teams, took away the pipeline to start with, then persistent data sources, that's a central part of what developers do, especially in even more now that we have many more of those databases in our distributed compute architectures. But we set up another team to build that and think about how that should work, both technologically and also from a sort of security and controls and data protection perspective. We set up cabs to do things. If any of you have been in some of the senior roles, executive roles in companies, you know that oftentimes we set up cabs just to make things go slower because we were breaking stuff as people wanted to do things more and more quickly. But that's what developers are facing, and so now take this and project it over time, not just one sprint, but year over year, as your organization is growing and shipping more and more of their customers' experiences in the form of software, and yet we're also growing and evolving this approach to dealing with all the security concerns that we have. It begins to really drag things down.
So how do we solve for some of these pain points, taking a look at those different stops that we saw along the way. And the thing that we sort of are putting out there, and we've coined a term for it, is compliance at the point of change. And what we're talking about here is the separation of duties between the verification or the doing of compliance work versus the verification of compliance work. Meaning we're splitting the responsibility of doing the assessment and the responsibility of verifying that that assessment happened. As an example, separate the verification of infrastructure configuration from the making and the doing of the infrastructure configuration itself. In other words, we want to shift the doing of compliant development left as far as possible, as close to the developer, but the enforcement of compliance at the point of change where it actually occurs. When we do this, we meet the needs of security, compliance, audit, while also giving developers the freedom to optimize their own pipelines. We do this with the concept that I mentioned earlier, compliance at the point of change. And this term, I bring it up again, is because it's been coined by Nic, Carl Nygaard, Martin Fowler, several others. So to give you a more concrete example of compliance at the point of change, something that many of you are probably familiar with is the Kubernetes admission controller. And this is an API that can be used to meet the pattern of compliance at the point of change. Now, what the Kubernetes admission controller does, for those of you that aren't familiar, is when you send a deployment to your cluster to the boundary of your environment, as we talked about earlier, there's an object there that is going to be parsed by that admission controller. And there's different technologies to do that. You can do it with pure Go or OPA or something else. We'll talk about those. But the point is, it's going to take a look at the different artifacts and things that represent that deployment. Now, the reason that this is important is because when you think about the traditional audit or compliance strategies of the past, when you do an audit, it's like once or twice a year, performed by some random company, by some random set of auditors, and the way that they go about doing verification of compliance or of audit is completely depends on the person. In this case, you're doing it with every single deployment in a consistent and repeatable pattern. So to give you a more concrete example, let's look at maybe Sneak. If the developer owns their own pipeline and they own Sneak in terms of that pipeline, they might have like a circle orb or something that they've written. They're going to create a report artifact or a CVE artifact that's attached to that container hash. Right? And when that deployment hits our boundary, our cluster environment, our admission controller is going to call back up to Sneak and say, does this deployment have any high or critical vulnerabilities? Are any of them accepted by the business, et cetera, et cetera? But the point is, the verification of compliance is done at that point of change or at the deployment. The actual doing of compliance work was already done by the developer. And they were able to do that however they wanted to. It might be the first step in their pipeline. It might be the last. They might have another automated process that generates those reports daily, hourly, minutely. Some of you have probably seen Ortelius here at the talk. That one does it dynamically. But the point is, those CVEs and those reports are generated however the developer wants to. They're just meeting the needs of the boundary of the environment when they actually get there.
So how might this look? We've got 2 or 3 particular examples that we want to put in here. And starting with this one is continuing on with CVE scanning, and I've put up here the security domain team. So if you think back to that dense slide I had with all the different teams on it, traditionally those are like functional silos within an organization. And so if there's optimizations and things going on, they tend to be happening inside of those functional silos. And so if any of you have worked with and thought about lean engineering and what that means, and instead of thinking about things in their silos, but end-to-end optimization and how to improve the actual outcome of that, the question you have to ask is, to be successful with that end-to-end approach, is can any one of these individual teams, have we drawn the boundary correctly? Is it the right domain? And in this context, it's a way of saying, well, okay, can they arrive at what they want to do in such a way that they self-serve, enable, and completely don't block what the other teams around them are doing. So it's very much a domain-driven design strategy like we think about when we're architecting our application that we're shipping to our customers. But the same thing applies here, and it can work if that team is approaching it this way, meaning There's many, but one of the things that they're responsible for is, hey, we don't want to ship code into our customer's user space that has known vulnerabilities that we haven't figured out or accepted or remediated. And how can they do that? Well, today we pick tooling to help us automate that process, but the idea is, yeah, get that in place. Provide keys. When teams come on board and they're using these things, give them keys that they can interact with and get that feedback early and do the work of remediating those issues or patching them, whatever it takes to fix it. And in this case, we use kind of a Circle CI example. The idea is, yeah, that security team could own building these versioned, reusable bits of pipeline code that then the developers who own their pipeline can just drop in and get that feedback. What are the vulnerabilities, if any? What are remediations available? And they're responsible to make them. Likewise, that security team could build and ship the admission controller, the validation that goes in and say, hey, do I see in our sneak logs, for instance, do I see the artifact that says, yeah, this particular git commit, this SHA was scanned, it had the right results at the right time, and so I'll go ahead and this deployment can go through. Or alternatively, if it's not there, we'll block it at that point. And so this compliance now we're talking about, at what point do we enforce that compliance? We'll do it at the point where the change occurs, and what we're checking is, did that work take place? Did it happen? Did developers own it? And whatever you do, if you're going to hold that domain, for instance, in this case, the security team, provide these tools that they would need to give that feedback and be compliant in completely independently consumable, self-service sorts of ways. We have kind of expression we bring to this former thought worker. He's now head of engineering at Ritchie Brothers, a great Vancouver company. But put it this way, if you have an opinion, then you better have developers. And the idea is that either if you're the security team, for instance, you provide the outcome and developers can self-solution to meeting it, or you have developers that create service interfaces, API endpoints, reusable bits of pipeline code, and automated gatekeepers at a control plane level that finally do the enforcement so that people aren't opening up tickets to get that work done. They're not engaging in that necessary human interaction for it. They have a self-serve way of achieving it. Put another example in, using the same team in this case, but bill of materials is something that's becoming more and more important. And here often what we're doing is saying, hey, here's an orb, for instance. Go ahead and generate a bill of materials for the information inside your image in this kind of distributed compute architecture. Here's another tool where you have the means to be able to sign these things so that we can trace provenance all the way back to that signed commit when it went into Git to this image that's now going to be shipping and running, the same exact image from dev all the way through prod if it's released. Here's the tools to generate those things and get them into the OCI registry so that we can put a admission controller on the other side that says, oh, hey, there's a deployment happening. I'm going to go do a quick check. Is this signed? Is it signed by the appropriate team? Is there a bill of materials with it? They don't generate those things, but they do a check on it to make sure that it's valid. And so the entire effort, this is one where, in fact, maybe none of those automations in the orb are there, but you could define those outcomes very clearly, and teams could self-solution in a way that would easily meet it, and yet still write, for instance, the security team could still own and write the admission controller in that case.
You just keep it. So for our last example, we're looking at maybe a slightly different case from the others where we're seeing scanning tools. We can talk about product ownership or development or the creation of user stories. And while at Thoughtworks we don't recommend doing manual gating your deployments, like having production owner sign off and then it's deployed, we understand that some enterprises still need to do this. And so in that example, most of those tools, Jira, Rally, et cetera, have an API. And so what you can do is call out to that API at the point of change, i.e. the admission controller still, and see if the product owner has signed off on that deployment or that user story. To do this in a better way, what we would recommend is maybe we define product approval or product owner approval as a series of criteria or a composition of criteria that have been met all at the same time, i.e. story has been admitted into the backlog, we've got a bunch of acceptance criteria that are being automated and tested and they're all passing, we have smoke tests, we have code quality, all of those things, when they're met at the same time, our product owner has already said, yep, if all those things are met, my approval is met. And we can additionally still, in that case, call up to our Jira or other API-based product ownership tool and see, oh, is this deployment allowed to go through or not? And maybe there's certain acceptance criteria that haven't been met or haven't been tested against. Well, then we can immediately deny that deployment into our environment until that is actually met. Yeah. Go ahead.
Yeah. Well, for my part, just to summarize, we see this consistently, and it's not just a sprint over sprint sort of thing or a month over month, but it's a year over year return on investment to say everything that makes up what a CI/CD pipeline is, that the actual ownership of that and the day-to-day code interactions with it, to maintain that in the development team's hands. Whatever other requirements there may be, give them self-service ways of meeting that, of doing the work to make it compliant, but also when you have to have, and we do want, enforcement gates, that happens early. It's all the way left in the sense that first data center deployment, these gates are in place, but you don't take away control from the teams to be able to do that. And it's one of, like I say, there's many things that create value and accelerate teams, but this is one that's consistently among the most valuable.
And just to go back to our sort of an earlier point, there's two things we want you to walk away from here. The first one is the single most friction-reducing thing you can do for a development team is give them ownership of their DevOps processes. By adopting compliance at the point of change, you can do exactly that while still meeting the needs of your security, compliance, and any other teams that have checks that need to be performed. And you can allow your development teams to do what they do best, using their intuition, like we talked about earlier, in order to drive their own processes. As you develop domain experts on your teams, if you have an application team that's been together for 1, then 2, then 3, then 4, then 5 years, eventually you're going to have experts on that team, and they're going to get better with time, and they're going to want to change their process because they realize that there's changes that they can make. Well, if that process is controlled by some arbitrary team or architecture board, like Nic said, or something else, they're not going to be able to improve and get better. The second point that we want you to walk away from is from the audit perspective. By taking this approach, we are, instead of doing 1 or 2 off audits every year, we're doing it continuously, and we're doing it with a pattern that everybody understands and expects and can speak to. And this is immensely powerful for both sides of the house, operations and development. I think that's the end of our talk. I've got another talk later today on flux at the point of change at 2 o'clock. Feel free to come to that. And feel free to reach out to us for questions. Thank you.